Welcome this lesson or this course. The title of the course is Quantitative Analysis for Business Decisions. This is a course for Masters in Business Administration class, and it's brought to you by Philemon Landi Tubey. This course is going to have 9 topics or chapters. The first one, we shall look at Introduction to Management Science, where we shall be looking at the operation research. Then topic 2, we are going to look at linear programming. Topic 3, we shall look at, so under linear programming, we shall use inequalities to do the maximization and minimization of business aspects. For example, we would want to maximize revenue, we would want to maximize profit, but at all the time, we would want to minimize losses. Then we shall go to inventory models. This is, you are aware that in whichever business, maybe in production or buying and selling, you have to put your merchandise or your product under your shelter or a building, and therefore it is very important that you can be able to track and understand what you have in, what you need to bring in, and what is going out. Then topic 3, we shall move to network models, where we shall be looking at the critical path method, as well as the PART, that's program evaluation and review technique, when it comes to activity scheduling or project scheduling. And that is where we shall look at what you have to do as a production manager. How do you schedule your production activities? If you are a sales and marketing staff or personnel, how do you do the same in as far as the market is concerned? Then topic 5, we shall be looking at Markov decision process. Those of you are aware of Markovian theory, Markovian model, where we look at, we use transition matrix to calculate the shifting loyalty of consumers from seller A to seller B, from seller B to seller A, or even production. So this one, we shall be looking at this aspect of movement or shifting of customers' loyalty from one company to another company, or from one producer to another producer. Then, then we shall move to decision theory, where we are going to use tree diagram and probability concepts for us to be able to predict and to do probability analysis and be able to come up with what we may want to produce or what we may want to purchase or procure into our business. Then we shall move to topic 7, which is transportation and assignment problems. So here we shall be looking at, for example, you are a transport manager. How do you look at origin of given goods, then destination, and how do you do calculations using Mogul and even the northwest point corner in calculating this? Then when we come to assignment, we are looking at like you have work, then you have advertised, and 4 or 5 companies have applied for it. They have given you the cost for each. They have given you the time. So how do you play around so that you come up with a given company, or even if you will offer all the 4 companies, maybe you have like 4 assignments, and you want to make sure each of them will have at least one stake or one work to do. So how do you distribute? How do you assign? But you are doing it statistically, not just out of imagination. Then chapter 8, we shall look at queuing models, theories. Like you are 10 of you in a line, you are to be served, and the server is taking like 10 minutes per one of you. So if you are 10, so and you are number 10, so you can be able to calculate or estimate the time you will wait before you are served. And this will go into even the server algorithm in virtual room. What happens like in the ATM machine? What is really happening, because it's first in, first out, then the duration for waiting and what have you, given that no 2 financial transactions will be allowed to take place simultaneously. And so we shall be looking at this. It's just enjoyable. Then we shall move to game theory, where we are going to look at the issue of using like the prisoner's dilemma in actually coming up with and in business application. So it will be very interesting, and this is a course that is enjoyable. It's a course that is practical, applicable, and you will see it. We shall just be picking some math theories and models, formula, then we apply, and you see how it will move. So we have to start. So, chapter 1, Introduction to Management Science. So we're looking at operational research definition, and therefore we are saying that operational research is the attack of modern science on complex problems arising in the direction and management of large systems of men. We are managing men at workplace, we are managing machines, materials, money in industry, in business, in government, and even in defense. So the distinctive approach is to develop a scientific model of systems incorporating measurements of factors such as change and risks with which to predict and compare the outcome of alternative decisions. So what would be essentials of the operation research approach? The above formal definition contains several essential features, and these are application of a model-based scientific approach. Number 2, systems approach to organizations. Number 3, the recognition of risk and uncertainty. Then number 4, assistance to management, decision-making, and control. Then what about application of a model-based approach? You will realize that the basis of the operation research approach is that of constructing models of problems in an active, factual manner and experimenting with these models to show the results of the various possible course of action. So a model is any representation of reality and may be in graphical, physical, or mathematical terms. Therefore, the type of model most frequently used in operation research is a mathematical model, i.e., one which tries to show the working of the real world by means of mathematical symbols, equations, and formulae. Yes. So an example of a simple mathematical model familiar to accountants could be the following equations to estimate the total overheads for a period of time. So like, for example, we would use a linear equation. In this case, like you take a function of y equals to a plus bx. Is a model of the relationship of total overheads to the number of units produced, where y is the total overheads in the factory or in the company, a is fixed overheads per period, and b is variable overheads per unit, which is assumed to be constant, and x is the number of units produced per time. So the above model is obviously very simple and most practical models, which are of necessity much more complex. Yes, it is important to realize that however complex looking a model is, and however many variables it contains, it still involves considerable simplification of reality, and any results or prediction obtained from the model, which must therefore be used with caution and judgment. Although mathematical or symbolic models are common, other types of models are like the heuristic, iconic, analog, simulation. Yeah, so let us start with iconic models in mathematics. They are visual models of real objects they represent. They may be larger or smaller than the reality. For example, a model steam engine is much smaller than the really steam engine itself, whilst the familiar colored plastic models of molecular structures are much larger. Yeah, when we are teaching molecules in class, for example, we use bigger, larger diagrams to illustrate a molecule when we know very well a molecule is minute, very small. You can't even see it with your naked eyes. So, both of these iconic models, and so are pictures, maps, and diagrams, although these latter are in a different form to the reality, reality. So it is okay. Okay, sorry. Why? So we are moving to analog model. Analog model. So the analog model here is where the use of one set of physical movement or properties to represent another set. For example, the movement of a piece of metal. Yeah, the movement of a piece of metal under stress. Yeah, under stress can be represented in a more observable form by the movement of a gauge finger. A gauge finger. Fathom lines on charts and lines on graphs are also analogs of the reality they represent. Although analog models are more versatile than iconic models, they generally lack the flexibility of mathematical model. Yes. So we move to simulation models. So a simulation model, it does represent the behavior of a real system. Perhaps the best known example is the flight simulator used in the training of pilots. Simulation models are used where there is no suitable mathematical model, where the mathematical model is too complex, or where it is not possible to experiment upon a working system without causing serious disruption, as in the case of the training of pilots. One application of simulation models in the management context is the study of the behavior of people and objects in queues, meaning in lines. When people are in lines, you know how they behave. Yeah. So, with the development of relatively inexpensive computing facilities, many business games are based on the stimulation of the operation of complete business. Let us move to heuristic models. These are models which use a set of intuitive rules which managers hope will produce at least a workable solution and a better solution than methods currently being used. For example, a delivery van driver may be instructed to plan the day's deliveries using the following rule. After each call delivery to the nearest customer whom you have not yet visited. So what happens is this, in essence. This will certainly give a good solution early in the day, but it can lead to some long distance being traveled at the end of the day back to the depot. The driver has no way of knowing whether the route gives optimum time and distances, and any improvements can come only through testing other heuristic approaches. Yes. Now, next, let us move to systems approach to organization. So we are simply saying that the primary aim of operation research is to attempt to identify the best way of conducting the affairs of the organization, i.e. optimum. So, in studying problems, the operation research practitioner tries to optimize the operation of the organization as a whole rather than narrow aspects of the business, such as a single department, section. So this is easier said than done. And because of the practical necessity of dealing with marginable areas of work and thereby producing simplified and incomplete models of operations, there may be a tendency to produce, there may be a tendency, there may be systems approach. So we are talking about a tendency to produce suboptimal solution, i.e. solutions that are not actually optimum. So we are very much interested in the whole model. So this is another point which should be watched when considering the results of an operation research investigation. Now, let us move to 1.6, where we are going to look at recognition of risk and uncertainty. This is common with all activities and projects and whatever production endeavors we are in, because there's none that is risk-free or zero risk. So we're saying this: all business planning and decision-making involves forecasting future activities. That is true. This cannot be done with any certainty, and so to provide the maximum possible assistance to planners and decision makers, a systematic analysis of the possible extent of the risks and uncertainties involved is a vital part of any operation research study. What are we trying to say? We're trying to say that operation research techniques do not of themselves remove the risks and uncertainties, but they are able to highlight their effects on the firm's operations. Therefore, an important method to help with this process is what is termed sensitivity analysis. So in our last chapter, we shall look at sensitivity analysis, that will come after transportation and assignment problems. So when a solution has been obtained using one of the operation research techniques, such as linear programming, inventory control, and even investment appraisal, alterations are made. Alterations are made. Yes. Yeah, alterations are made, to the factors of the problem, such as sales, costs, amount of materials, to see what effect there is on the original solution. We're saying also, if the value of the original solution alters considerably with minor changes in the factor values, it is said to be sensitive, meaning like if you make a small change in the independent variable and it causes a big change in the dependent variable, then that is the aspect of sensitivity. The aspect of sensitivity. Okay. In such circumstances, the whole problem will need much deeper analysis, and a particularly sensitive factor may cause decisions to be altered. Always we are altering, we are changing decisions. We don't, because you see the environment, both internal and external, are dynamic. And therefore, every time we are making decisions that are dynamic in essence, because as the world is changing, we equally have to make changing decisions to be able to cope up with the changes that are happening in our external and internal business environment. Now, we want to look at assistance to management, decision-making, and control. Yes. So in general, operation research practitioners do not make the business decisions. They don't. These are just practitioners. They are experts. They are consultants. Their role is the provision of information to assist the planners and decision makers, because they generate, operation research practitioners, they generate data, which now will be used by business decision makers to make business decisions. The skill, experience, and judgment of managers cannot be replaced by formal decision-making techniques. So what are we trying to say here? We're trying to say something important, that the results of an operation research investigation are but one input of information into the decision-making process. what I'm saying here is that I'm not trying to say that absolutely it's only operation research data or information that business managers use wholly to make decisions. This is just one part of input. But you see, in business, we use numerous, various sources of information apart from operation research data to make decisions. That's what that sentence is trying to tell us. There is a strong parallel between the operation research practitioner supplying information for management decision making and that of other information specialists such as accountants. Because yes, fine, we are going to get information from operation research. That's okay. But as a business manager in an organization, in a company, in a firm, you also get information from the accounts department, which will show cash inflow and cash outflow. You also make use of information coming from the marketing and marketing and sales and marketing department, production department, procurement department, etc. Well, so this is why a knowledge of operation research for the accountant and accountancy for the operation, for operation, practitioner can be very useful and can improve quality of the information provided. Meaning, when you source information from various sources, at the end of the day, the business decision you are going to make will be information-based and multivariate information or data-based. And therefore, the decision you make is going to be a cognitive, concrete, comprehensive business decisions. So there are strong reasons why the most effective or teams contain people drawn from various backgrounds. You need economists, you need accountants, you need mathematicians, you need engineers, you need psychologists. You see, in industry, we have industrial psychology, etc. In this way, there is more chance that the numerous facets of business problems can be recognized and analyzed. There is this aspect of quantification factors, because here we are going to deal with statistics, and therefore the aspect of quantification, quantitative data is very important. So I'm saying that not all factors involved in a decision-making or planning, situation can be quantified, but the most readily usable operation research, research techniques are those based on quantifiable factors such as costs, revenues, number of units, etc. These techniques are the ones most commonly included in examinations and form the basis of the syllabuses of the major professional bodies. Hence, the contents and title of this book, and the whole course for this particular course or chapter, in as far as the introduction to quantitative analysis for business decisions. Therefore, you will agree with me that quantitative aspect, this is yeah. So as I come to conclusion, you find that management science is very important when it comes to managing people, managing businesses, managing equipment, managing material, managing time in as far as a business manager is concerned. Therefore, this is a very important kind of area that business people, business managers, or business administrators need when it comes to managing their businesses. And once we manage our businesses scientifically and not just out of imagination, then we are going to succeed because this is very important and this is very crucial, if not very pertinent, in as far as students who are pursuing Master of Business Administration is concerned. Therefore, if there is no question, no comment from you, my students, I would call it a day, and thank you very much. I look forward in seeing you in our next lesson, where we are going to look at linear programming and see how we shall use inequalities to do the optimization and minimization of business aspects. In this case, we will be looking at like if you are given the cost function, cost of production function, how do you lower the cost of production? So meaning how would you minimize the cost of production? And when it comes to revenue function, we are interested in maximizing revenue. If you are given business profit function, we are interested in maximizing profit in as far as business is concerned, because we are in business to make profit. And whenever we have a chance to make a profit, we make maximally. Whenever we have a chance to make revenue, we make maximally. And in a case where we are making losses, we should make minimum losses. Otherwise, thank you very much. Have a good day. Enjoy your summer, and let us meet in our next lesson. Bye-bye. See you. And please revise what we have learned. Revise